Today, we are introduced to activity 124, which right here is turtle escape. And so what we're doing in this code is we are generating a maze, right? And as we said, we're going to start off very, very, very simple, right, with the absolute basics of this. And then what we want to eventually do is be able to generate this maze at random. And so just to kind of recap here before we begin with this part of the pseudocode, the very, very beginning, we just started off with just the very basic pseudocode where we created that spiral, right, where it was the background or the actual maze itself without any doors and without any barriers, right? And so we ended up constructing our pseudocode for just that basic maze creation without the doors or barriers. And then what we ended up doing is later, we moved on to adding in the door. And so as we were talking about, we're using a for loop, right? For wall in range 25. This is going to be the case where we're going to complete 25 iterations of this, right? And so what we end up doing is we end up establishing a variable door location. And so door location for us is equal to 10 pixels, right? So what we're going to do is we're going to move forward that door location, right? Then we're going to do pin up. Then we're going to move that path width, which is what was specified in the e-text that the door should be. Then what we ended up doing is we did a pin down, and then we ended up moving the remainder of the wall, which was x, right? Now, in terms of x, how do you calculate that out? Well, right over here we have our little diagram. Wall length is supposed to be equal to the door location, which is 10 pixels, plus the path width plus x, right? So if we don't know x, we can solve for that using this equation, just basic subtraction, right? So you take wall length minus path width minus door location. You end up finding x, which is that remaining section we need to move. Now, this is where we were talking about should be going off in your head. We're going to run into some issues, right? Now, this is only going to work if the wall length value that we end up having is greater than path width plus 20, which we ended up saying we could just do path width times 3, right? Because if it is less than this, we're going to end up running into some issues whenever we calculate out x. We're going to basically get a negative number. It's going to cause our code to go kind of crazy. Also, shout out to Doe. Follow his Instagram. He's starting up the coding business. Anyways, let's go ahead. Let's move on. So then what we ended up doing is we added in our barrier, right? So this was our barrier pseudocode. Now I end up crossing this out, right? Remember on our notebook, we always want to date and initial if we cross something out because it's a mistake. So we end up talking about the add barrier code. And so what we're doing here, still same iteration here, right? I just ended up abbreviating this so I wouldn't have to write these out. This is door location. This is path width here. We got pin up, pin down, then move to barrier location. So that's where they introduced the barrier location. Now keep in mind that did need to be equal to 40. We don't want to actually have that hard-coded in our code, though. The 40, we're going to use variables. So this is something else that we need to establish, right, up in our initialization variables. Or you can end up doing that within the code because eventually we're going to end up getting a random number for that. But then what we're going to have to do once we reach the barriers, you got to turn left 90, go forward, then you can go backwards. Now, what's that value we're going forward and backwards? It's the value of path width, right? We did establish that as well. And then what we can end up doing after we've done that, we got to turn right 90 so that we're facing north again, in this particular scenario, that is. And then we want to go forward that remaining length of x. Now, keep in mind, if we end up calculating this out, x is going to be equal to the wall length minus the door location. Ooh, and this is an actual error in my code, minus, and then minus the barrier location, and then minus the path width, okay? Let me go ahead and put a date on that, 10/1 DR. So ended up updating that. So these should all be subtracted, right? Because we should have it be the case where this plus this plus this plus x here, it's going to end up equaling the wall length. So we're just solving for x in that equation there. So then we now know how far we need to move forward for that, okay? Now, this is where we ended up talking about this. This is the most recent part that we're at. So this is the random barrier and door location pseudocode. Now, this is based off of random values generated for location of the door and barrier, right? And so what we're going to do on each of these iterations is at the very, very beginning, we're actually going to generate a random value for our door location, and then also for the barrier location, okay? Now, the two options that we have is it could be the case where we end up having where the door comes before the barrier, right? Now, in this case, it's going to end up looking something like this, right? So here's our diagram. Maybe our door is going to spawn right here. And so this is door location, right? Now, we have the door here. We're going to end up going a certain distance, right? And then, so this distance here, we can put in here path width. That's what we said that should be, right? Then we're going up vertical. Remember, we do pin up, go path width, go pin down. Then we go some point along here, right? And so let's say that we end up finding out that the barrier needs to occur right here. Keep in mind, this is also path width that we're moving over there. But then we come into this issue here. Okay, so we'll draw out some extension lines. We're bringing the dimension lines back from IED. Then we're going to go right here. So then this will be like the remaining portion of this. So where this is the wall length, right? And then we've got it where this is the case from right here to right here. This is the barrier location. So we got door location, we got path width, and then we got barrier location. Now right here, what you might end up doing is try to go pin up, move path width, go pin down, and then you might try to move the barrier location value. Keep in mind, we are not actually wanting to move that entire barrier location here. It's going to be barrier location minus the door location minus the path width. Now, just so that I can ensure that everything fits here, I'm going to go BL minus path width, right? So minus path width minus D underscore L. Now, keep in mind, this stands for barrier location, path width, and then DL's door location, okay? So then we're going to turn left 90, go forward, go backwards, turn right 90, and then go forward that remaining distance. So this is option 1 here, right? So option 1, door before barrier. Okay, so what we're going to end up doing in this case is for wall in range 25. And then what we're going to want to do is we're going to want to first determine the random values for the barrier location and door location. So get random door location, and that's saved to a variable, right? Then we're also going to get the random barrier location. Okay. Now, in this, if, and then what we can do is we can do if the random door location is less than random barrier, door location less than barrier location, then we want to actually create this, right? So it's going to be at this point right here. This is the code that basically we're going to create to do this. So if the door location comes before the barrier location, then what we want to do is move door location, right? Then we want to go pin up, PU. Then move path width. Then pin down. Then we want to move, so we were saying it's going to be the barrier location minus path width minus door location, right? And I'm starting to feed into this side a little bit too much. I was trying to have it option 1 and option 2 over here. But then we're going to move that distance, right, which is going to be right here. Then what we want to do, turn left 90 degrees, move path width. let's put it in parentheses, forward, then backwards, turn in. So it appears that it ended up cutting out on us here. But then what we'd want to do, I'm going to use the phone here to block this other part, is you'd want to turn right 90 degrees. And then at the very, very end here, right, after we turn right 90 degrees, we're going to be facing up that initial location. Then we're going to move that distance x. Now be mindful of this. Our distance x is going to be equal to our wall length minus our barrier location, right? Because x plus our barrier location is going to be equal to wall length. So just by solving for x, you can end up finding that distance you need to move to get that remainder part of the wall, okay? What I also did here is I did draw out option number 2. Now, this is the case where the barrier comes before the door. Now, if the barrier comes before the door, then we're going to need to have this happen. Now, I created the diagram for you. I want you to compare this to your pseudocode, right? But I'll kind of walk you through this. What we're going to do first is we're going to end up moving forward barrier location, right? You're going to turn left 90, go forward path width, go backwards path width, we're going to turn left 90 here. Turn left 90, go forward path width, go backwards path width, then turn right 90 so that you're facing that initial direction. Then you're going to move, I have this as abbreviated, door location minus barrier location because that's the distance we've already traveled. We're going to go forward there, right? Then pin up, move forward path width, pin down. Then we got to move this remaining section x. Now how this works out mathematically is x plus our path width plus the door location must be equal to our wall length there. And so if you solve for x in that equation, you end up getting this, right? And so that's that remaining portion of the wall, okay? Now, in terms of these two options, we've mentioned these two options. However, there actually is a third option here that we have not mentioned. And we need to take this option into consideration before we even begin to check these options out. That third option of what could end up happening is it could be the case, what if the door is equal to the barrier? So what if we end up having it where it looks something like this, right? Here's our door, and then we have a barrier up here right there. Well, we wouldn't want that to happen, right? So we don't want that to happen. So we want to end up setting up our code so that it can take that into consideration, right? Now, what we could specify also is what if they're just also like really, really close to each other too, right? Maybe you want to have some good spacing between them. So maybe you want the spacing to be equal to path width times 2. So what we can do, just like we did in the collision detection program for turtles in traffic, we ended up using this function called ABS. Now, what is that? That is to find the absolute value in Python. And so what I can do is I can put in some mathematical, we can perform subtraction, addition, multiplication, any of that, and we can end up getting the absolute value of it. So if I take the door location minus the barrier location, that'll find the difference or how far away those are from each other, right? If we take the absolute value, then we can test to make sure that these two locations are at least path width times 2 distance away from each other, right? So now what I had initially here was an if statement. Now, if we do that where it's an if statement, then it's going to be the case where it's only going to check that once, and then it's going to generate these new location values. Then it could still be the case where those locations are within this certain distance from each other, right? And so instead, what we could do is we could use a while loop. Now, remember, a while loop is going to occur while this is true. We're going to continue to do this action right here, right? So what a while loop would do is it would make sure that we keep on generating these new location values until they are at least path width times 2 distance away from each other, okay? Now, in terms of where are you going to put this code in terms of if there's the issue, right? Remember, we have the for wall in range 25 here. What we said that we need to do from the beginning is get the random door location and get the random barrier location, right? And so where we're going to end up putting this code right here is we're going to pop it in right here, right? So that it's between this get random barrier location and also the if statement. So it's going to go in between those two lines of code, all right? So hope that this run through was helpful for you all. Happy coding. See you all in the next video. Bye-bye.